part of Unit 7 has to do with various types of polygons and the measures of their interior and exterior angles. So these are the ones that you guys picked up from the table on the way in. It's just basically a chart for you to fill in. You're going to do this with a partner. You guys are going to fill in the chart with the information that they're asking for. So it says first to name the figure. So remember, a figure is named based on how many sides it has, right? So this shape had 4 sides, so we know it's a quadrilateral. So that's what goes in the first column. They drew the sketches for you. You won't have to do any of those. But it says what you are going to do to each one of these figures is divide each polygon into triangles by drawing all diagonals from one vertex. So you pick one vertex. So maybe I picked this as my vertex. Okay? You can only draw from vertex to vertex to create your triangles. Well, if I draw from vertex to this vertex, that doesn't create a triangle, right? That wouldn't do anything. But if I draw from here to here, it splits it into how many triangles? 2. And if I drew to this vertex, again, it's not going to create a triangle. So really the only line that split into triangles was this one right down the middle here. Okay? Then it asks for the number of sides that this figure has. It's got 4, right? Okay, and then it asks how many triangles were formed by the lines we drew. So you guys said it gave us how many triangles? 2. That's what will go in this box. And then they ask for the sum of the interior angle measures. Well, what's the sum of the interior angle measures of a quadrilateral? 360. All right? So with a partner, I want you guys to fill in the remainder of the chart, and then we're going to check our answers together here in just a minute. Okay? I'll give you guys a second to do that. So, on the second figure, what kind of shape is that? Pentagon, how do we know? 5 sides. Good. Okay. And if it has 5 sides, that's what goes here. And how many triangles was it split into? 3. Okay. All right. And then for the next figure, what is it? An hexagon. Good. Because it has how many sides? 6. And it splits into how many triangles? 4. All right. What about that next figure? What's that? Heptagon. Good. Because it has how many sides? 7. And how many triangles can I split it into? 5. All right, and then for that last figure we see drawn, what shape is that? Octagon. Because it has how many sides? 8. And splits into how many triangles? 6. Okay. All right, so this last column really is the only one you have to put some thought into to figure out what it could potentially be. We didn't start with a triangle drawing, but you guys know that the interior sum of a triangle is what? 180. Okay, so one triangle has a sum of 180. How many would 2 triangles have? 360. So this had 2 triangles, so that's why it's 360. So if this one makes 3 triangles, what would its interior sum be? 540. Okay, and if this one makes 4 triangles, what would its interior sum be? 720. Okay. All right, what about our heptagon? What would its interior sum be? 900. And our octagon? 1080. Okay, so easy enough if it's a figure that we can draw in the triangles for, right? But if you had a 30-sided figure, you wouldn't want to have to draw in all the lines, right? So we need a rule. We need to figure out, how do we know how many triangles it's going to have just based on the number of sides the figure has? Right. Every single one of these to go from here to here was just -2, right? So if this thing has n sides, how many triangles is it going to make? N minus 2. Okay? And what do we multiply by to get this last column? 180. So if it has n number of sides, it's going to have an interior sum of 180 times n minus 2. All right? Okay, so now that we know that information, if you flip it over onto the back of this page, it asks for the interior sum of a few figures here. All right, so if I have a 15-sided figure, what's its interior sum going to be? Okay, what about a 20-sided figure? Okay. All right, then we have a decagon and a dodecagon. If you don't know what those sides are, look it up real quick. Decagon is 10-side, What is a dodecagon? How much? 12. Okay, so what would the interior sum of a decagon be? What is it? Good. 1,440 degrees. What about a dodecagon? How much is it? Yeah, it should be 1,800. Yeah. Okay. All right. So we have filled in the information to find interior angle sum for all of our polygons. Now, if you will flip it over onto the next page, we're going to talk about exterior angle sums. All right, so whenever you are trying to find your exterior angle measures, exterior means outside of the shape, right? So the shape itself is just this right here. We extended those sides out to create these angles on the outside, okay? You only will draw these lines out in one direction. So we drew them out here, here, and here. You'll go clockwise or counterclockwise to create these. And you only go, like I said, in one direction. I would not want to extend this line out this way too, or that way too, okay? We're only going to go out one direction from the angle itself. So what they ask you to do for this activity is they want you to find the measure for each one of these angles and then add those up to tell us what the exterior sum is for whatever the angle measures are for that specific figure. So you are going to take your protractor and you and your partner are going to measure in degrees how many degrees each one of those angles are, and then fill in the sum of the exterior angle measures. So let's do the first one together. What's the degree measure of angle 1? Okay, remember your 0 needs to be on one line all the way to the other. What did you say, Les? 115, very good. Okay, how many degrees is angle 2? 90. And how many degrees is angle 3? 155. All right, so to find the sum, all we're doing is adding those up. So what is the exterior sum here? 360. Good. Okay, now I want you and your partner to do the same thing for the next two figures. You're going to find their measures using your protractor and then find their sum for the next column. I'll give you a second to do that. So for this second figure, what was the measure of angle 4? 110. All right, what about angle 5? 70. And angle 6? 110. And 7? 70. All right, so when we added all those up, what did we get for the sum of our exterior? 360. Okay. All right, let's look at that next figure. What was the measure of angle 8? Good. And angle 9? Good. Angle 10? Good. 11? And angle 12. Nice. Which gave us an exterior sum of 360. Okay, so the figures that we just found an exterior sum for, did any of them have the same number of sides? No. So it seems like it doesn't matter how many sides it has, the exterior sum is always going to be 360. So for an n-sided figure, it's still going to have an exterior sum of 360. Okay. All right. So in this next section, it says for the following regular polygon with the given number of sides, find an interior angle and an exterior angle. Okay. So let's start with the first one. Let's look for our interior angle first. All right, so to find our interior angle, what did we say our formula was? Right, good. So this would be 180 times n minus 2. That's 30 minus 2, so really 180 times what? 28. Okay. So what does that mean that one of our interior angles should have a measure of? Okay. So that's the total, right? That's the sum, right? Okay. And if this thing has 30 sides, how many angles does that mean that it has? Okay, a triangle has how many sides? 3, and it has how many angles? 3 angles. So it has 30 angles. So if I want the measure of one angle, what do I need to do to this number? Divided by 30. Okay. They said that these were regular figures. Regular means that all the sides are the same size. So all the angles should be the same size. All right, so what do I get when I divide? Very good. Okay, and that was to find the measure of one interior angle. Now we're going to find the measure of one exterior angle. Okay, well we know that the sum of the exterior is always what? 360. But I need to divide that into how many angles? 30. So what's the measure of one exterior angle? 12 degrees. All right. All right, I'll let you guys do it for 2, 3, and 4, and then we'll check our answers together here in just a minute. 2, our figure was an octagon, right? So what did we set up? 180 times what? 6, and then we divided it by 8. So what did we get for our interior angle there? 135. All right, and then for my exterior, all I had to do was divide my 360 by 8. So what did we get for that one? Good. All right, for my 12-sided figure, I did 180 times what? Divided by, very good, which gave me what? 150. Alright, and then when I did my exterior angle, what did we get? 37. Alright. Okay. For the last one, we had a heptagon. Okay, so we did 180 times what? 5 divided by, good, which gives us approximately, okay, 128.57 or 128.6, whatever you chose to round to will work. Okay, what about for my exterior angle? What do we get there? Okay. Okay. All right, and then if you'll flip it on to the last page, we have 2 more examples to look at. So for number 5, it says that the measure of one interior angle is 140. They want you to figure out how many sides the figure had. So we can still use the same formula, we're just solving for a different piece this time, right? Okay, so to find an interior angle, what's our formula again? Good. 180 times n minus 2 gives me the sum. What do I do if I want to solve for just one angle? Divide it by the total. And again, do we know how many sides it has? So I have over n, right? Okay, is equal to what they say that one angle had a measure of? 140. Okay. All right, so I need to solve for n. First thing I need to do is get n out of the denominator over here. So how would I do that? Multiply both sides by n. So those divide out, right? Okay, so now I have 180 times n minus 2 equals 140 times n. So what would we want to do over here? Distribute, right? What is 180 times n? And what is 180 times negative 2? Good. Is equal to 140 n, right? Okay, what should we do now? Okay, so what is 140 minus 180 then? Okay, so I have negative 360 equals negative 40n. Then what do we do? Divide. Okay, what is negative 360 divided by negative 40? 9. So n is 9. It has 9 sides. All right. Okay. Next question, similar, but this time it's talking about an exterior angle. It says this exterior angle has a measure of 72 degrees. Find the number of sides. So what's our formula for finding the measure of one exterior angle? Right, 360 divided by n. And apparently it equals 72, right? So what am I going to do to solve here? Multiply both sides by n. So 360 equals 72n. Then what do we do? Right, and what are we going to end up with? So this thing has 5 sides. It might also ask you for the name of that shape. What would a 5-sided figure be named? Okay, it's fine. Good.